Welcome to the new video. Students, in this lecture we are going to solve a problem of homogeneous differential equation of the standard book MD Raisinghania of section 2.8 and exercise 3. So without wasting the time, let's begin the journey. What it is saying? It is saying that solve this equal to this. Okay. So students, as we know that at first we have to write the given equation in this form, that ddx of y is equal to something, and students see it is already of this form, right? So let's write it. Given that what is given, that ddx of y will be equal to this one, right? Now what we have to do? So now we have to write that let y equal to vx and let it be equation 1, right? And put it as equation A as usual. Okay. So now by differentiating 1 with respect to x, we get, what will we get? We will get that it will be dy by dx, right? And it will be v, and if you differentiate this one, right, then it will be equal to 1, so it will be v plus, now we will take x as constant, and now if we take the derivative of v, then it will be dv by dx, right? Let it be equation 2. So students, as usual, now we will put the equation 1 and 2 in the equation A, right? So do it by using equation 1 and 2 in equation A. We get, what will we get? We will get this term, that what it will be, see, what is dy by dx? Here dy by dx is equal to this term. So the equation A will be equal to, if we put it, then what it will be? It will be v plus x ddx of v will be equal to, now see, it is y by x, right? And we know that y is equal to vx from equation 1, right? So write it here, y is equal to vx, write it by x plus tan y is equal to vx by x, right? We are doing nothing but just putting the value of y and ddx of y, right? So see what it will be. Now do the simplification. So if you do the simplification, you will get this, that v plus x ddx of v will be equal to, see, this will be cancelled, so v plus this will be cancelled, it will be tan v, right? And students, see, this v and this v will be cancelled, so what will be the remaining expression? So the remaining expression will be x ddx of v will be equal to tan v. Okay. Now we will separate the variables, right? So take all the v terms to one side and all the x term to another side, right? So take it to this side, so it will be dv by tan v, right? And it will be equal to, if we put this x by dx to this side, then it will be reciprocal, so it will be ddx of dx by x, right? Now students, see, all the variables had been separated. Okay, so now we can write that integrating both sides with respect to x, we get, what will we get? We will get that integration of dv upon tan v is equal to integration dx upon x, right? And it will imply, see, tan v, can we write it like that, tan v equal to, sorry, it will be dv by sin v by cos v, right? and it will be equal to this one, right? Now let me change the color, white, color of peace, right? So see, it will imply that it will be cos v by sin v, right, of dv, and it will be equal to dx by x. Students, see, I have done nothing but just the simplification, that when this term will go upside, we will get the reciprocal of it. See, I hope you are able to understand, right? These are basic things, okay? So now integrate it. So students, see what it is. This is sin v and this is cos v. Okay, so see, what is cos v? This is the derivative of sin v, right? So what we get? We get that here is sin v and its derivative is in the numerator, right? So what will be the integration? So the integration will be log of sin v, right? As we know, these are very basic things, okay? And it will be equal to integration of this one, and it will be equal to log x plus log c, where log c is the arbitrary integrating, this is integrating, okay, integrating constant, right? So now it will imply that log sin of v will be equal to log of cx, right? From here we are getting it by the property that, see, here is the property that log a plus log b is always equal to log ab. Basically this is the standard result, okay, of logarithm. So I hope you know it, and if you not, then just remember it, that this holds. And it will imply that, see, log, so it will be cancelled, so it will be sin v is equal to sin cx, right? And students, see, still this is not the result. Why? Because here is v. What is v? We will get it from this equation, right? So write it. It will imply v equal to y by x. Let it be equation b, right? So put it here. So it will be sin y by x will be equal to cx, right? And students, see, where c is my arbitrary integrating constant, right, and which is my required answer. So students, this is the solution of this problem. I hope I am able to make you understand each and every step. And if you have any difficulty, if you have any doubt, if you have any question, then ask your doubt in the comment section, right? Because the comment section is only for you. I will make you proper reply, right? So finally, thank you for watching the lecture, and I have written a very beautiful line for you, that mathematics is the most beautiful and most powerful creation of the human spirit by a great mathematician, Stephen Banach. And all the best for your mathematical journey, and see you soon in the next video. Thank you.